Let x and y be positive constants. Which of the following is not equivalent to log base 3 of x plus 3 plus 2 log base 3 of x minus 1 minus log base 3 of x plus 2? All of these have the same base, which means they combine. Now, you always want to combine things that are adding first. When adding two logs of this, oh, I didn't even notice that. This has a 2 living out in front. I take it back. This is the first thing you want to do. If you have a coefficient attached to a log, you're allowed to take that number and set it as the exponent to the stuff inside the log. So that middle guy becomes log base 3 of x minus 1 squared. Log base 3 of x plus 3 doesn't change, so we'll write that out. X plus 3, that's still there. Minus log base 3 of x plus 2 is still there. Now we can deal with these Christmas guys that are combining through addition. When you add two logs of the same base, you multiply the insides. So this guy becomes log base 3, and let me add these brackets, of x plus 3, x minus 1 squared. And then on top of that, we're subtracting log base 3 of x plus 2. Always take care of the addition stuff first. Now what we have is we have the subtraction guy that's just lingering out. When you subtract two logs of the same base, you divide the insides. So this whole thing is now going to become log base 3 of that guy, x plus 3 times the quantity x minus 1 squared, all over that guy, x plus 2. Now to find out which one of these is not this. Well, we have our answer already. It's A. In none of these, like, I'm looking at these and you're saying, okay, I see what they want. This guy is a mirror image. These guys are exactly the same. I can rewrite out x minus 1 squared as x minus 1 times x minus 1. So B is good. C is the same. And if you look at D, you see the x plus 3. And if you're thinking, oh, wait a minute, x minus 1 times itself, x minus 1, foils out to x minus 2, x plus 1, this is eventually the same. In none of these cases do I have a coefficient of 2 lingering out here. So A is going to be my answer because A is the guy that's not the same. Isn't that fun? Logs.